No, it's Clive Roxinger here. I've got my little power meter up and running, and it was knocking out 3.8 watt, and it turned out that the power supply uses up about a watt of power, which I can calculate the voltage drop. So what I'm going to do now is I designed a circuit to deliver DC power to the other circuit. I set up a set of battery packs, which was these ones here. It was an 8-pack and 2 singles, and it delivered almost the same power, but what happened was the voltage was a little bit higher, and because of that it was putting more power across the circuit. And although I got nearly the right number, I didn't get exactly the number that I wanted. So what I've got to do now is I've got to create a 12 volt circuit using these rechargeable batteries, but they only charge to about 3/4 of their value. So I'm going to have to use 2 packs. So I've got a 10-pack and a 4, and that should knock out about 16-18 volt. And then what I've got to do is use a voltage divider and a very high wattage resistor, which is this one here. Now this is a 30 ohm, but it's a 50 watt. I think this cost me about 30 bucks. Or they were 60. I think I got that fairly cheap. I think it was only $35. And I think they call that a rheostat. But that's a real chunky devil, that thing. That can handle a lot of wattage. Now you need fairly low ohmage when you're doing stuff like this. When you want to pull a lot of power across it, you need a fairly low resistance, so 30 ohms more than enough. Now what I've got to have is I've got to have some elbow room. Is I make a voltage divider, and all a voltage divider is when you've got resistors like this. When you put the meter across that, that's actually a voltage divider. If you put an output on that resistor, you're going to get at that particular one there on the N1, what was I getting at 6.28 volt, I think. Well, you could drive a 6.28 volt circuit with that. So the idea is that you have 2 resistors in series, and you come off that in parallel. So you've got your parallel terminal coming off it, but in between that parallel you've got a series circuit with a variable resistor, which is this one, and then you've got a fixed resistor. And what I have to do is get it close to the value that I want. I've got to design the upper and lower ranges, and then use the variable resistor to compensate and get exactly the right voltage. And what I do is I'll put a meter on the resistor that I know what the values are, and it's got to equal exactly 6.28 volt. And so what I do is I just turn the dial on the resistor, the variable resistor, until I get exactly that value, and then I calculate the current. Well, then I measure the current in the circuit with the multimeter, and so that's how you've got to do this. But designing the circuit's tricky because you've got upper and lower values. You've only got a small ohmage to work with, so I'm going to have 18 volt, and I've got to try and figure out a circuit that will deliver exactly the right voltage to it. And I have actually already determined this, but it wasn't close enough for my liking. And as I say, when you're doing science, you've got to get it dead on. This resistor's a bit inaccurate because it's it's wire wound, and because of that, it's very sort of grindy when you're turning it on, and you can't get it accurate. Once that starts to get a bit smoother, that will it'll be easier to get more accurate numbers, but at the moment it's a bit sort of clunky. Yeah, see, it's gone a little bit too far, and I can't get any accuracy out of it because it's brand new, so it's hardly been used. But I'll try and get the values as much as I can, as close as I can. It's only got to get within, reasonable range to as long as I establish that the wattage across the circuit is what I expect it to be. Things should work out alright, but this is where circuit design comes into it. Another thing with these battery packs, with these little ones, I've got a switch on and off with them, but these ones don't. And when I was when I was wiring up a circuit, I had wires dangling down, and I had the batteries in the battery pack, and I had the wires dangling down in front of my knees, and two of the wires touched, and it actually smoked the unit. I'd chuck it out, but could have wouldn't start a fire, but it could have could have damaged some stuff. So what I do now is I screw them together, and if you don't learn from your mistakes, then you're probably not going to get very far. I suppose with AES the rule of thumb is we don't dangle. You can dangle on occasions, providing you're careful, but when you've got a lot of stuff on a table like this, having both of those are live, you've got to be bloody careful of this, and so that's why I very carefully laid them out like that. But you've got to pull a battery out to make sure that it's not a complete circuit, so you've got to be real careful with these power supplies. So you're dealing with high wattage now. And the wattage in the circuit's going to be probably maybe 5 watt, or maybe might even get up around 10 watt. So I've got to be careful when you're dealing with a bit of wattage. You can burn yourself or whatever. Yeah, not good. So as a general rule, I don't dangle anymore, and I'm going to wire those up. But for the time being, I've got them in there. I've recharged all of them. And one trick I found to this was I had the wrong type of recharger. Get one of these. If you've got rechargeable Coles batteries, get one of these. The one that I had was taking 3 hours to charge batteries. That charges in about 15 minutes. And boy, gee, when it finishes charges them, they're as hot as. And it's the right type. It's an NIMH. So you got to be careful. There's NiCad and then NIMH. You've got to be careful that you don't use the wrong type. So yeah, but that's something I found out recently. So anyway, things are going alright. Clive Rocksinger, over and out.